So in this unit, we're learning about a lot of gas laws, and I'm just giving you a taste of some of them. One of the gas laws that we're not going to be studying, but one that we see in our day-to-day life is Avogadro's law. And Avogadro's law is a relationship between moles and volume. And a good example of this is when you have a flat tire. So your tire has a certain volume and you have a certain amount of air molecules in that tire. And how do you blow the tire up? Well, you have to put more air molecules in it. As you put more air molecules in it or increase the number of moles, what happens to the volume? The volume goes up. And so this is a direct relationship. So you increase the moles, you increase the volume. Avogadro studied gases, and he noticed that it didn't matter what type of gas he used, that as long as he was at standard temperature and pressure, or STP, the volume of that gas would be 22.4 liters. So if he was using carbon dioxide or oxygen, as long as he had 1 mole of it, he would have 22.4 liters. This was mathematically calculated to determine Avogadro's number, which is the number of atoms in a mole. And of course, that number is 6.02 times 10 to the 23rd. So this is just one of those gas laws that we see, but we don't really have problems on in this unit. You are going to have problems on the combined gas law. So in the combined gas law, we have, on the top, we have, this is Boyle's law. So remember, as pressure goes up, volume goes down. So it's an inverse relationship. And then we also see Charles's law right here. And this is, as the temperature goes up, the volume goes up. So in the combined gas law, we've combined these gas laws. We can use this if the pressure is changing, the volume is changing, and the temperature is changing in the situation that we're looking at. So let's look at an example problem. So we have a balloon, and it has 250 milliliters. So this is my first volume, this is my V1. And then atmospheric units, this is my P1. And we have our temperature. This is our T1. Now remember, this is degrees Celsius, so immediately turn it into Kelvin. So this is 298 Kelvin. All right, you let go of the balloon. So sad face. What is the volume at? And so this is what we're trying to find. And then here's our second pressure. And this is our second temperature. And remember, we need to change that to Kelvin. So that would be 288 Kelvin. And we assume the number of moles stays the same, so this is our combined gas law. We want to solve for V2, so let's get V2 all by itself. So a lot is going on here, so make sure you really pay attention to what unit you are substituting here. So my pressure cancels, my temperature cancels, so my second volume is left all by itself. And let me just clean this up here. All right, so we're going to plug into the combined gas law. I've just rearranged it to solve for the V2. And we can cancel units. Atmospheres cancels, Kelvin cancels. So my unit is going to be in milliliters. This is my V2. When you're looking at these numbers, we're going to multiply all those numbers across the top and then press enter. And then the numbers in the denominator, make sure you press the divided sign first. So I'll press divided by 298 and then divided by 0.25. So don't times by 0.25. It's in the denominator and you'll get the wrong answer if you put in your calculator wrong. And so for my answer, I get 725 milliliters. So this is a situation where our temperature is going down, so we might think that the volume goes down, but notice that our pressure also goes down, and it has a greater effect on the volume of the balloon. So there's an inverse relationship between pressure and volume. So as pressure goes down, volume goes up, and we see that overall our volume will go up in this case because the pressure changes more dramatically than the temperature does. All right, this should be question 23 in your packet, or at least one that's close to that number, a combined gas law problem. And let's go through and identify what's what in our problem. So we have our V1 right there. Liters is a volume unit. This is a pressure unit, And there's my temperature unit. It's already in Kelvin for us, so I don't have to change it. Here is a second temperature, and here is a second pressure, and it says what volume. So that's what we're solving for. So this one's going to be very similar to that last one that we just did. So write your combined gas law formula. We want to solve for V2. My temperature and pressure will cancel, and what you do to one side, you do to the other. And so then I have V2 is equal to P1 V1 T2 over T1 P2. And let's plug in each of those values. Cancel our units. So we have kilopascals canceling and our Kelvin canceling. And we're going to end up with liters as our unit for this. And remember those numbers in the denominator, we want to divide them. So for our answer, we get 98.7 liters.